Hello, 108 class. Mr. McHugh back here with you. Section 1.1. We listen to me. 8.5. Excuse me. And I forgot to give you the name of the terminology here. What do you do whenever you have a radical down in the denominator? We rationalize it. Okay, that's the buzz phrase we're going to use to tell you that we don't care for radicals in the denominator and we need to deal with them. Okay, so example 2C starts off kind of a fairly easy one again here. Now, I showed I showed an alternate way and a primary way. The first method up here, the first method is called simplifying. I kind of recommend this because I think it makes life a little easier. And what it is you look at the square root of 12 and can you simplify that? And the answer is yes. Break it apart, pull out a perfect square root. Square root of 4 times the square root of 3, which you'd write as 2 times the square root of 3. Then you would see negative 6 divided by 2, divide that out. There you get 3 times the square root of 3. And that's your answer until you say, oh, we have to rationalize it. That's our buzz phrase to tell us to deal with and get rid of radicals in the denominator. So there's the square root of 3. It's prime. You multiply it by square root of 3 times the square root of 3. Stack it because that's equal to 1. And now you've got 3 times the square root of 3 is 9, square root of 9 is 3. So what you realize quickly is when you multiply a radical by itself, the result is always just the radicand comes out. And then up here we got 3 times the square root of 3 with the negative up here, and then finally 3 over 3 cancels out and you're left with negative square root of 3 as your answer. Okay, so far so good. Example 3A. Now you've got a fraction, so you know you can break apart the numerator and the denominator radicals. I encourage you to break down square root of 18 into perfect square root factor, square root of 9 times 2. Don't forget the minus sign. And I want to pause here for just a second because guess what? I didn't explain up here. This alternate way is just to show you that real fast. Let me do this. If you take a radical, you multiply it by itself, you'll still get the same answer. So you get square root of 12 times the square root of 12, which is square root of 24, which is 12. It boomerangs back the radicand. Stack it because it equals 1. Like I said, you don't change it. And here's what you get. Negative 6 divided by 12. Here's your 2. And square root of 4 can be broken down into square root. Square root of 12 can be broken down square root of 4 times square root of 3. That's 2. Negative 1 times 2. You cancel out and you're left with the same answer. Whew. Okay, take whichever way you like, I guess. Recommending the simplifying. I think it makes it just a little easier to deal with. Okay, sorry about that. Let's jump back down here. And what can we do about 18? Break it down. Perfect square of 19 times square root of 2, 125. 25 times 5, there's a perfect square root. So we've got this here. Execute the perfect square roots. You've got square root of 9, negative 3, square root of 25, 5. Okay, now down in the denominator, what are we left with? That radical is this times the square root of 5. We don't care for it. That's prime, so I'm going to multiply by the square root of 5, and I'm stacking it because it equals 1 again. And what's the result? So you've got square root of 5 times square root of 5. 25 square root is 5. 5 times 5 is 25. Okay, watch those little details here. Up here you've got what? Negative 3 on the outside of the radical. Underneath it you've got the same index 2, so 2 times 5 is 10, and there's your answer. Okay, let's try 3B. What do we got? Well, move down just a little bit maybe here. Looking at 3B, and it says the square root. I see fractions. You see it broken apart. As you separate the numerator and denominator with the radicals, square root of 50 can be broken down into 25, square root of m to the 4th. Okay, p to the 5th, I'm going to break down into square root of p to the 4 times p, square root of p to the 1st. Okay, and wow, I don't know how I made that symbol appear. Let's try this one more time. Okay, we're going to roll with it. And that's the square root of p. And when I execute the square roots, I got 25, m to the 4th. Remember, cut the exponent in half as a shortcut. Cut the exponent in half, square root. Again, wow. When I say cut the exponent in half and you see p to the 4th square root. Can't you put the 2? Use your right hand L rule, roll it up. 4 divided by 2 is 2. There's your p squared. Okay, and you still got the square root of p. Now, how do we rationalize it? What's the radical down in the denominator? Square root of p. So multiply by that and stack it. So you've got p squared, and then you've got square root of p times the square root of p, which is the square root of p squared, and that turns out to be p to the 1st. Okay, p squared times p to the 1st, multiply by the same base, add the exponents, you get p to the 3rd, and you got you up to top what we had left over. Nothing to simplify here. 5m squared square root of 2p. Okay, and you got it. Okie dokie. Let's see if we can do example 4a here. Rationalize with cubes and 4th roots. Okay, it gets a little tricky. You're dealing in cube root mode. Separate numerator denominator. Cube root of 27, 3. Love it. Cube root, not, see, you gotta watch this. It's not the square root. This is where people will make a mistake. They're going to write 8 here and they think they're done and they're going to be wrong. Watch that on a test, a multiple choice. That is a classic case where they'll put the answer -3/8. Square root of 16 is what? 4 3/4, and students will select it and think they got it right, and they fell for the trap. So watch that. Okay, so I'm going to take 16, break it into cube roots. Perfect cube roots is what? 8. Cube root of 8 times the cube root of 2. Cube root of 8 turns out to be 2. 2 times 2 times 2 is 8. And now in the denominator, I have to rationalize the cube root of 2. Now this gets a little tricky. They usually don't make these too bad, but you got to go to perfect cube roots. So 2 times what is 2 times what would give you like a perfect cube root, and I'm thinking 8. I try to show the work down here. So 2 times 4 is 8. The cube root of 8 is 2. So that's, you want this to be your rationalizing factor. So why did I pick that? Because 2 times 4 is 8. Cube root of 8 is 2. Here's this 2 is along for the ride. Up in the numerator, you leave it alone, and so you got your 3/4. They took 2 times 2 is 4. 3/4 times the cube root of 4, and you got it. Okay, class. Good news. I've mentioned this term way back, so this will not be surprising to you. But the concept of conjugate is a binomial multiplied by its opposite, and hopefully you're getting very good at recognizing it. Here's a binomial. First term, second term with a plus or minus. And if it's multiplied by its conjugate, it'll have the same first terms, same second terms, and the plus and the minus will be their opposite signs. Okay, so, and if you have that, you take the first term. When you have this is telling you to take the first term, square it, subtract because it's the difference of squares, take the second term, and square it. Okay, that's how I like to write that form. Okay, so we're going to pick more up on that on page 3, so I'll see you then. We're going to sign off here now. Good job, everybody, and I'll see you for page 3. Okay, bye.